Okay, good evening, everyone. Welcome to today's live class. Um, we'll be starting in a few minutes. I just want to add my students to the live session. I want to add my WhatsApp students to the live session, and then we'll start. Just give me 1 minute. Okay, I think we are ready. So welcome everyone who has joined the live session. Glad to have you here. So in our previous lesson, we looked at area of a trapezium. We saw how to calculate the area of a trapezium when we are given the length and the height. We also saw how to calculate the length when we were given the height and the area. And we also saw how to calculate the height when we are given the length and the area. So in today's class, we'll be focusing on area of a rhombus. Area of a rhombus. So first of all, we need to identify what a rhombus is. What is a rhombus? What is a rhombus? So as I said, the first thing we need to identify is what is a rhombus. Hello Cecilia, nice to see you. Good evening. Good evening, nice to see you. So what is a rhombus? A rhombus is a four-sided 2D shape with equal sides and opposite angles. Confidence, good evening. Comfort, good evening. Today's class will not be that long, to be a little bit short, okay, because we are only focusing on rhombus. So a rhombus is a four-sided with equal sides and with opposite angles equal to each other. So a rhombus is a quadrilateral, okay? It's a little bit similar to a square, but it is not a square. It is similar to a square in the sense that it has equal sides. Remember, a square has all its four sides equal to each other. So that's the similarity between a rhombus and a square. All the four sides are equal. But unlike the square, whose angles are also equal, for a rhombus, only the opposite angles are equal. Okay? So let's draw a rhombus. A rhombus looks like a kite. Some students confuse between a rhombus and a kite. So we're also going to look at the difference between a rhombus and a kite. So let's draw the rhombus first. I'm not the best at drawing, but I think I did a good job. Okay, so this is a rhombus. How do we know it's a rhombus? All the four sides equal. All the four sides of this rhombus are equal. So that's the similarity between a rhombus and a square. All the four sides are equal. But unlike the square, whose angles are equal, for a rhombus, these two angles are equal, these two angles are equal. So these two angles are bigger than these two angles. Also, for a square, the diagonals are equal. But for a rhombus, the diagonals are not equal. Remember, a diagonal of a 2D shape is a line drawn from one angle to the opposite angle. Okay, so when you see a rhombus like this, let's call it diagonal 1, and then we call this diagonal 2. So if you look at the diagonal from here to here, it's longer than the diagonal from here to here. So the diagonals are not equal. For a square, the diagonals are equal. For a rhombus, the diagonals are not equal. Also, for a rhombus, the diagonals are lines of symmetry. A line of symmetry is a line that divides a 2D shape into two equal parts. So these diagonals divide the 2D shape into two equal parts. So they are both lines of symmetry. So this is a rhombus. Now I'm going to draw a kite because many students confuse between a kite and a rhombus. When we were little children, we used to construct something like this, and then we used to make it fly in the air. So we used to call it a kite. So as adults or as older children, we assume that this is a kite. But for a kite, the diagram would be so this is a rhombus, this is a kite. For a kite, you can see that one part of the kite is longer than the other part. Okay? For a rhombus, if you cut it at the middle, both sides are equal. But when you draw a diagonal like this, for a kite, this side is shorter than this side. So that's the major difference between a rhombus and a kite. Okay? For a kite, only one of its diagonals is a line of symmetry. If you draw a line from top to bottom, it's going to divide the kite into two equal parts. But if you cut it through this other diagonal, it's not going to give you two equal parts. But for a rhombus, the two diagonals are lines of symmetry. I just wanted to add that, okay? So let's go back to what we are doing. So now, how do we calculate the area of a rhombus? The formula is area is equal to half d1 times d2. Half d1 times d2. The formula is half d1 times d2. Okay. Please, if you are from the WhatsApp group, please indicate so that I will know that you are here. I know Cecilia is here, Confidence is here, Comfort is here. Okay. Okay. So now the formula is area is equal to 1/2 times d1 times d2. d1 is the longer diagonal, d2 is the shorter diagonal. Victoria, nice to see you. Good evening. Okay, so now we're going to look at some examples. As I said earlier, today's class is going to be Obedience, nice to see you. Today's class is going to be a little bit short. From our next class on Wednesday, we will be looking at circle geometry. Okay, circle geometry. Sorry, circle theorem, not circle geometry. Circle theorem. That's what we'll be looking at in our next class. Okay, now let's look at an example. Benedict, welcome. Nice to see you. Okay, so we have sorry, I'm not the best at drawing. Okay, so this diagonal eight centimeter, 6 centimeter. So in this question, the diagonals are the longer diagonal is 8 centimeter, while the shorter diagonal is 6 centimeter. So once you are given a question where you're told to calculate the area of a rhombus and you are given the two diagonals, then the question is very easy. All you need to do is apply the formula. So area is equal to half d1 times d2. So our d1 is equal to 8 centimeter, d2 is equal to 6 centimeter. So it's quite easy. So this gives us area is equal to half times 8 times 6. So 4 times 6, which is 24 centimeter square. So when you are given a question like this, it is quite easy to find the area of the rhombus because you are given the two diagonals. Okay. So we're supposed to add this to our previous class, but we overshoot our time from our last class, so I just had to finish with this set of topics, so we'll go to the next one. Okay. So what about a situation where you are given a diagonal and one side? Then how do we go about solving it? If you are given a diagonal, but instead of you to be given two diagonals, you are given only one diagonal and then one side. So how do you go about solving it? That's the next example we are going to look at. Can we continue? Can we continue? I guess we can. Let's continue. So another example. How do I explain again? Were you not part of the class when I was explaining? Francis, nice to see you. Okay, so in this question, we are giving one of the diagonals and then the side. Remember, all the sides are equal. So 5 centimeter represents all the sides. So in this case, 24 Okay, I think you are giving answer to the previous example. Okay. So in this case, we cannot use the original formula, though we are still going to use the formula, but we first need to find the second D. We know that area is equal to half times D1 times D2. So we know only one D. D1 is equal to 8 centimeter. But we don't know the second D. We don't know this side. So let's just draw it. Now, if from this point to this point is 8 centimeter, then from this point to this middle is going to be 4 centimeter. From this point to this middle is going to be 4 centimeter. Then if you observe that we have a triangle like here, a right angle triangle here, let's bring out that right angle triangle, because we are trying to find this length. Because for us to solve the area, we need to know this second diagonal. So if we bring out this triangle, we are going to have we're going to have 4 centimeter. We're going to have 5 centimeter. Then from here to here, we don't know what it is, so let's call it x. So we know that this is a right angle triangle. Okay. Humble, nice to see you. Good evening. So, Daniel, nice to see you. So we don't know this. We don't know from here to here. We need to find this diagonal in order to find the area, in order to apply this formula. So that's why we need this smaller triangle in order to find this length or this base. So we can observe that this is a right angle triangle. And for a right angle triangle, in one of our previous lessons, we've learned that if you know two sides, you can use Pythagoras theorem to find the third side. Okay, so this side is our hypotenuse. So we can simply say c squared is equal to a squared plus b squared. C is the hypotenuse, so 5 squared is equal to 4 squared plus b, let's call it x squared. So 25 is equal to 16 plus x squared. X squared is equal to 9. Therefore, if you find the square root of x squared, if you find the square root of 9, you're going to have x is equal to 3 centimeters. Okay? So we've gotten x to be 3 centimeters. So remember, x is from here to here, which is this triangle we got here, this triangle. So that means from here to here will be what? If we have x to be 3 centimeters, what will be from here to here? Who can tell us from here to here? What will be the value? What will be the value? What will be this value from here to here? This diagonal, what will it be? 6, correct? So that means this diagonal D2 will be equal to 6. So D2 is equal to 6 centimeters. So we have already solved this example before when we did the first example. So area is equal to half times 8 times 6, which is 4 times 6, which is 24 centimeters squared. So it's just the same example. Confidence says 7. How is it going to be 7? Remember, from here to here is 6. Sorry, it's 3. So double of it is going to be 6. Double of it is going to be 6. Richmond, good evening. Nice to see you. Mainness. Are you from the WhatsApp group? Is it mainness? Mainness. Are you from the WhatsApp group? Chief Rahim, good evening. Please, some of you who have been joining the live class, you've not contacted me on WhatsApp. I'm really serious with removing those that are not joining the class from the group. So if you have not contacted me, please send me a message on WhatsApp. Chidera, good evening. Send me a message so that I can save your number. At the end of the month, if I don't save your number, when I'm removing those that don't have names in the group, because once I save your number, it will change to a name. So once I'm removing those that don't have names, I will end up removing your name, your contact, because it is I did not save it. You contacted me, please contact me again at the end of the class. Immediately the class ends, contact me again, please. Most times I get so many messages from TikTok, persons contacting me from TikTok, so, and also my one-on-one students. Hello, Marcia, good evening. Okay, so we've been able to calculate the area of this rhombus by first finding the missing diagonal using Pythagoras theorem. Okay, so we are going to solve another question. In this situation, we are going to have I think in one of our previous classes we've done SOHCAHTOA. Was anybody in that class when we did SOHCAHTOA? Was any of you in that class? Oman Emmanuel, good evening. Was any one of you in that class when we did SOHCAHTOA? That was last year. So we're going to look at a situation where you are given the sides and angle. So there might be situations. Oh, was it my previous group? Because it's expected that once we are 1 year in the group, I'll end up deleting the group, because I expect that you guys must have gone through all the topics that I'm supposed to teach for 1 year. So I will delete the group and start afresh with a new set of students. Probably I've not done it with you guys, probably, but I think I've done it. I just have that belief. Okay, so probably I will not do that. We're going to solve another question where there is one side and there is one angle. But how many of you have learned about SOHCAHTOA before? How many of you have learned about it? Okay. So I'm going to look at an example where we need to apply SOHCAHTOA. Then, if you have not learned about it, I will leave a link to the lesson where we did some studies on SOHCAHTOA. I will just leave the link in the WhatsApp group so you can go check it out. So let's look at another example. Okay. So we are expected to find the area of the rhombus in this form. So you are given one side and you are given one angle. You are given one side and you are given one angle. Let's write the angle this way. 96 degrees. Okay. Remember, these two angles are the same. When we define the rhombus, I told you that the two opposite angles are the same. So in this situation, we are not giving any of the diagonals. We're only giving one side and one angle. So how do we find the area of this rhombus? So the first thing we do is we draw the diagonals. And then we draw this one. Let's call this point A, B, C, D. And this point here is point 0, point O. So when this diagonal cuts this angle, what will this angle be? What will be this angle? When this diagonal cuts it, what will this angle be? What will this angle be? If this diagonal cuts 69 degrees, if it bisects 96 degrees, what will it be? Any answers? 48 degrees. So once this diagonal from here to here is 96 degrees. But when this diagonal cuts it into two equal parts. So each side is going to be 48 degrees, right? So we can now draw it. Let's look at this triangle here. Triangle AOB. So let's draw triangle AOB. So this is AOB. So we know this side to be 12 centimeter. We know this angle to be 48 degrees. Okay. So with this side and with this angle, we can apply SOHCAHTOA to find these two sides. Let's call this side X. Let's call this side Y. So with this, we can find the value of X and we can find the value of Y. Okay. So remember SOHCAHTOA, for those who have not learned about SOHCAHTOA, remember I said I'm going to drop the link to the lesson so you can check it out. Or if you've learned it but you've forgotten. So means opposite over hypotenuse. So this slanting side is the hypotenuse. So means opposite over hypotenuse. So wherever the angle is, the side facing it is the opposite. So if you want to find X, you're going to use which is sine. So we can write sine 48 degrees is equal to X over 12 because it's opposite divided by the hypotenuse. Yeah, does anybody have a calculator? Can you tell us what sine 48 is? What is sine 48? Let me bring my calculator out. Sine 48 degrees. What do you have? Sine 48 degrees. I've gotten mine. So we can still say sine 48 over 1 is the same thing. So has anybody gotten 0.7443? Yeah. Or 0.74, okay, the same thing. So we can do x times 1 will give us x. We have 0.743 times 12. So what will that give us? 0.743 times 12, what will we get? What will we get? 8 point, because of time, 8.92. 8.92, okay? So x is equal to 8.92 centimeter. Okay, so we've gotten the value of x. Remember, x is from here to here. What we are seeing as this is from here to here, okay? So next we get the value of y. So y is here, y is the adjacent. So this will give us adjacent over hypotenuse. Adjacent over hypotenuse. A represents adjacent, H represents hypotenuse. So we can have cos 48 degrees is equal to y over 12. Those of you that it seems you're lost is because you've not learned about this, okay? So you can just step back to go and check it at the end of the class. So what is cos 48 degrees? Cos 48 degrees. 0.68. I got 0.67. Can someone do the final confirmation? Oh, 1.7. No. Cos 48. It should be 0 point something. So we have 48 over 1. So y is equal to cos 48 is 0.67, okay? 0.67 times 12. 0.67 times 12, what will it give us? Okay, 0.67, okay? 8 points. You got 8.9. Okay, I think that's the previous, that's for x, okay. 0.67 times 12, what do you get? Nobody has gotten the answer. Maybe we'll go with mine. Mine is, okay, 8.04. 8.04, okay? So y is equal to 8.04 centimeter. So now let's take those values back to this diagram. So y is from this middle to this point. X is from this top to the middle. So if this is x, this distance, and this is y, this distance. So that means from here to here that means our d1 is 2x because it is double of x. Our d2 is 2y because it is double of y. So d1 is equal to 2 times x, which is 2 times 8.92. What will that give us? 2 times 8.92. Hope you guys understand what I did. This is x. So double of it is 2 times x. Two times 8.92. $17.84. So we have D1 is equal to 17.84 centimeter. Okay, so D2 is equal to 2 times y. Y is 8.0, which will give us 16.08 centimeter. So we've gotten our D1 and D2. We've gotten our D1 and D2. So now we can calculate the area of this rhombus. Calculate the area of this rhombus, which is area is equal to half times d1 times d2. So we have half times d1 is 17.84 times d2 is 16.08. So what would that give us as our answer? What would that give us as our answer? In two decimal place. Yeah, I told the people that came early we are going to look at circle theorem from our next class. Circle theorem. So what's the area of this rhombus? What's the area? Lawrence, nice to see you. You can just watch it again at from the beginning at the end of the class. Nobody has gotten the answer. Half times 17.84 times 16, 143.43. Okay. Okay. So the area is called 143.43 centimeter square. So that's the area. Excuse me. So we've seen how to calculate the area when we are given the two diagonals. Sorry. When we are given the two diagonals, we've seen how to calculate the area when we are given one diagonal and one side. Now we've seen how to calculate the area when we are given one side and one angle. So these are three situations that can occur if you're expected to calculate the area of a rhombus. You might be given the two diagonals and you're expected to calculate the area. You might be given one diagonal and one side. Remember, all the sides are equal. So one diagonal, one side, and you're expected to calculate the area, or one side and one angle, and you're expected to calculate the area. So these are just the three different situations that can occur. Okay, so I'm going to give you a question to solve. That question will involve one side and one diagonal. I think most of you came when we looked at one side and one angle. So I think that's what I'll leave as a classwork before we end today's class. So if you came late, you can just watch the video again. Then also, if you did not understand how we solved SOHCAHTOA, I'm going to leave the link to the lecture on SOHCAHTOA so I can just go over it and learn. Okay. So try this classwork. Nice to see you watching from Lukulu. Where is that? Which country is that? I'm going to change it a little. Okay. So this is just a question I just brought out. It's not from any paper, so it might not be a very perfect question, but it's perfect enough for you to solve. Zambia. Okay, nice to have you in the class. I love to visit Zambia um, in the nearest future, especially Zambia, South Africa, Zimbabwe, those Southern African countries. Botswana. Um, I love the videos I've watched about those countries. Namibia, yeah. I have so many followers from Namibia. Yeah, if you, hope it's the question is about mathematics. If it's about mathematics, go ahead. So we have about 7 minutes to try the question. 7 minutes, and which we've spent 1 minute 1 minute already. Do you offer tuition like diploma? Okay. Mm, how many of you are in that same situation? You don't have calculator. Uh, okay. If you need any calculation that involves angles, just put it in the comment section. Someone will give you the answer, or I will say the answer. I will say the answer. You were asking, do you offer tuition like diploma secondary maths? I don't really understand what you mean. Is it like to give a certificate, or to like tutorial, one-on-one tutorials? We are not from the same country, so sometimes the way we use words might be different. So I'm struggling to understand what you say, offer tuition. Tuition over here in my country means the amount of money you pay for school. That's how we say it, tuition. I do one-on-one tutorials, but um, most times I don't come to agreement with uh, the clients in Africa. We don't come to agreement in terms of pay, right? So the amount of money they expect me to charge is not what I charge. So most times, uh, you know, many persons in Africa, when they calculate the amount of money I charge back to African currencies, they'll say no, 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 no. So that's why I decided to teach for free. So if you're an African student, okay, sign 32. Sine 32. Sine 32 is 0.53. I'm giving it to two decimal places. Sine 32 is 0.53. Sine 32 is 0.53. Cos 32 is 0.85. Cos 32 is 0.85. Cos 32 is 0.85. Sine 32 0.53. Cos 32 0.85. Okay, I don't know if you're on WhatsApp. On YouTube, I don't think there's an option for you to send me a message directly. I don't think so. I don't think so. I don't think so. Let's see. I'm going to, are you on WhatsApp? Musole, are you on WhatsApp? So I'm going to leave my WhatsApp number and then um, delete it at the end of the live class. If you're on WhatsApp, I'll leave my WhatsApp number so you can send me a message, then I'll add it to the WhatsApp group. So in the WhatsApp group, you can, okay? So Richmond said 90.1 centimeters square. Okay, good. So let me write it down, 90.1 centimeters square. Ninety point one centimeters square. So as I was saying, if you're on WhatsApp, just let me know. Then I'll leave my WhatsApp number so you can just write it down and then contact me at the end of the class. So we have one person who has gotten an answer. I didn't say the answer, an answer, because we've not confirmed if it is correct. Any other person giving us an answer? Okay. Rhombus says 90.1 centimeters squared. Okay, so two persons. We need one person, one more person, then we do the correction. And that will be all for today. So our next topic is circle theorem. Circle theorem. Circle theorem. So we're going to do that Wednesday and Friday. We should be done with it on Friday. Thank you so much. Okay, so I'm going to leave it here. So it's my WhatsApp number. WhatsApp. You can only contact me on WhatsApp. If you don't have WhatsApp, you cannot contact me because I won't pick the call. It's a direct call. So I just sent it with my second. You can see Charles Agbani. Yeah, that's the number. So once we are done with the live class, that number will go off. Okay, some other person got. Okay, you got 90.4. Other persons got 90.1. Okay, probably it might just be approximation issues. Okay, now let's look at it together. So if we draw the diagonals, so 64 degrees is going to become 32 degrees. So if we call here x and we call here y, for now, sorry, Friday class, we've shifted it to Saturday. We shifted the class to Saturday of Friday class because my one-on-one classes quite a lot on Friday. So I don't want to be disappointing you guys. So we just shifted it to Saturday. Even on Saturday, I still have a lot of classes, but I think that will be easier for me. Okay, so now we have this triangle. Y, X, 32 degrees, and 10 centimeters. So we can find X by using opposite over hypotenuse. So sine 32 degrees over 1 is equal to 10, sorry, X over 10. So X is equal to, we got sine 32 to be 0.53. So we have 0.53 times 10, which gives us 5.3 centimeters. Okay, and then for y, we have cos 32 degrees over 1 is equal to y over 10. So y is equal to cos 32, cos 32, 8.5. So we have 0.85 times 10, which gives us 8.5 centimeters. Okay, so that means our d1 is equal to 2 times y, which is 8.5 times 2 give us 17 centimeters. Our d2 is equal to 2 times 5.3, which gives us 10.6. I'm just trying to round up quickly. So finally we have the area is equal to half times 17 times 10.6. Okay. 17 times 10.6. Then divided by 2. So it's actually 90.1. Well done, everyone. Well done. Okay, so that brings us to the end of the class today. Richmond was saying, please, Friday class is too early by 6:30. I think, as I said, we moved it to Saturday. And Saturday's class, I try to fix it around my one-on-one tutorials, and the best time for Saturday for me is 6 p.m. Nigerian time. If you're in Ghana, it's 5 p.m. Ghanaian time. Okay, the 2 is because y is from here to here. So to get the diagonal is double of y. That's why it's 2 times y. And then for x too, x is from here to here. So double of x will give you from here to here. So that's why we multiply them by 2. That's why I'll multiply them by 2. Okay, good. Okay, so that will be all for today. Our next topic is circle theorem. As I said, I'll post the link to the SOHCAHTOA, the the the, the, the tutorial on SOHCAHTOA, so that those of you that are not conversant with it can go and learn it. Also, I said, if you have not contacted me, I don't know what time it will be. What time is it in is it Zambia? What time is it right now, so I can give you the equivalent time for you? It's going to be 6 p.m. Nigerian time. I think that should be about 8 p.m. Zambian time, because I think Zambia is 2 hours ahead of Nigeria. Right now it is 9:38. So I think it's almost midnight over there. So right now it's 9:38 or 9:39. So if your time is 11:39, so that means you are 2 hours ahead of us. I think in most cases you need to have a calculator. There are some angles that you can use. You can find without calculator, but not 32 degrees. I don't think so. I will check if there's any way to get 32 degrees without a calculator. So that should be all for today. We'll see on Wednesday, same time, 8:30 p.m. Nigerian time, 7:30 p.m. Ghanaian time, and the time in your country. So have a wonderful evening. Good night.